So one more video with log rules. What I want to focus on in this video, unlike the previous video where we learned how to use our log rules to expand logs, in this one I want to use the log rules to contract the logs, essentially do the opposite of what we did in the previous video. Instead of starting out up here and turning it into something that looks like this, start out with something that looks like this and turn it into something that looks like this. And as long as you're comfortable going in both directions with the 3 different log rules that we introduced in a previous video, that shouldn't be an issue. So here's an example. We're rewriting this as the log of something. That's a pretty poor prompt. I was just a little bit lazy. I could probably write that more intelligent, but hopefully you understand what I mean. Right now I have 3 different logs with coefficients out in front of them, and I want to rewrite that as a single log without any coefficients out in front of them. So how would I do that? Well, maybe first we can take care of the coefficients. It's tempting to try to put these 2 together immediately using your second log rule for this negative, but you can't because there's a 3 here and a 1/2 here. But we could use our second log rule if this 3 weren't here and this 1/2 weren't here. And it's easy enough to get rid of that 3 and that 1/2 by taking the 3 up into the exponent on the x and taking the 1/2 up into the exponent on the y. And while I'm here, I guess I might as well take the 2 up into the exponent on the z. And this is going to work out perfectly fine, and I'm going to continue this train of thought over here. But I want to show you a little hint at this stage. If instead of bringing the 1/2 and the 2 up into the exponent, you brought the negative 1/2 and the negative 2 up in the exponent, it'll end up being a little bit easier for you. So see if you can understand how you get from this line to this line, or from this line to the log of x cubed plus the log of y to the negative 1/2 power plus the log of z to the negative second power. At any rate, we'll finish this red one in a minute, but I want to keep going with the blue the original way I did this. What you might want to do at this stage is, I could use my second log rule here. I have the log of something minus the log of something else. Don't worry about this term for now. Let's just deal with these 2. I could rewrite that as the log of x cubed divided by y to the 1/2 power. And then we just have this log of z squared hanging out to be dealt with in the next step. What I now have is the log of something, it's a fraction, but don't worry about that, minus the log of something else. Again, my second log rule is going to come into play. My second log rule says if you're subtracting 2 different logs, you can rewrite that as a quotient. So what would that look like? I guess it would be x cubed over y to the 1/2, and then I would have to take that and divide it by z squared. Oh, this is getting really ugly. I got fractions inside fractions, but that's okay. Maybe we know how to deal with that. Maybe you know that when you have a fraction divided by a whole number, what you want to do is rewrite it as a fraction divided by a fraction so that you can use the fact that the quotient of 2 different fractions is the same as the product of 2 different fractions. You just have to multiply by the reciprocal of the denominator. What I'm saying is take this thing and flip it upside down and then multiply it by this fraction. You get x cubed over y to the 1/2 times 1 over z squared. Or if you wanted to write this all as a single fraction, you could say it's the log of x cubed divided by y to the 1/2 z squared. I guess you could argue that in any of these 3 lines, we technically had the log of something, which is what the prompt asked us to do. Although typically when you have fractions inside fractions, it's a good idea to simplify a little bit further and leave your answer either like this or like this. I kind of prefer this form, but whatever. Either of these are totally fine. That got a little bit difficult there at the end, got kind of ugly with the fractions inside fractions. Fortunately, there's a way to avoid all that. If you want to avoid all that, just use your first log rule instead of your second log rule, because the first log rule will just change this into multiplication. This plus right here allows me to write the first 2 terms as the log of x cubed times y to the negative 1/2 power. And then I still have this log of z to the negative 2 power hanging out. And now I have the log of something plus the log of something else. So I get the log of x cubed y to the negative 1/2 z to the negative second power, which I guess would be totally fine as your final answer there. Often people don't leave negative exponents in their answer, and if you were such a person, you might rewrite this as x cubed over y to the 1/2 times z to the second power, which would be the same thing that we have down here. But the point is this or this would be equivalent based on this weak little prompt that I gave you. And maybe you see that, it's a lot easier to apply my first log rule than it is to apply my second log rule when I have multiple negatives like this. It's also worth pointing out that you can go straight from this line all the way down to this line. You could sort of make up your own version of the first log rule that says when you have the sum of 3 or more different logs, you can rewrite that as the log of the product of those 3 or more different arguments. You can go straight from this line down to this line. One more example and then we'll call this section good. E raised up to this crazy power, we're asked to simplify this thing. Really, the reason I wanted to do this example is to show what not to do, because people want to look at this and be like, oh, the E and the natural log, don't those cancel each other out? Because the natural log of x is really the log base E of x, and when the base on the exponent and the base of the log match up, isn't there some sort of way that those kind of sort of just go away? If you're thinking that, that's great. That's kind of this statement that we have here, that b raised up to the log base b of x just equals x. This b and this log base b, informally speaking, cancel out, and we're left with just this x that used to be up in the exponent. Now it's kind of down on the main line. Really, this is the composition of two different inverse functions, b to the x power and log base b of x, and when you compose together a function and its inverse, you're left with just the variable x, the identity function. That's all great if you're thinking that, and that is what we're going to use on this problem. However, not immediately. We can't just go canceling out e's and natural logs. If this were e to the natural log of something, then we could cancel them out and we'd be left with just that something. However, it's not the natural log of something. It's the sum of several different natural logs that have coefficients, and I also have this constant out here. What I need to do is rewrite this numerator kind of like what I was supposed to do with this prompt. Rewrite it as the log of something, because if it was the log of something, then I'll be able to cancel it out with this e. So really what we're going to do in this second example, you could almost think of as a second version of this thing here. We don't have the same prompt, but in order to simplify this, we need to rewrite the numerator as a single log. How are we going to do that? Well, same logic. Let's first get rid of the coefficient. So let's call it the natural log of x squared plus the natural log of y squared minus 3. And then let's use our first log rule to put these two guys together. And so we can call it e times the natural log of x squared times y squared minus 3. And here you have some options. I think this minus 3 is really hard to deal with, and I don't think you should be able to see this, but let me show you two things that you could do. If this were the natural log of something, then I could use my second log rule to put this natural log and this natural log together. And you're like, yeah, if, right? It's not natural log of something, it's the number 3. Okay, but if I could write the natural log of something and that expression, natural log of something, were equal to 3, I could replace this 3 with that expression. What I'm saying is, because the natural log of e to the third power is just 3, I can replace this 3 with the natural log of e cubed. Whoa, okay, that got weird. Let's talk through that a little bit. First off, are we sure these are the same? Are we sure 3 is the same as natural log of e cubed? Yes. Why? because the natural log is the log base e. So the log base e of e cubed is asking you the question, what power do you have to raise the e down in the base up to make it equal to e cubed? Well, e to the third power is equal to e cubed. So the natural log of e cubed is just 3. So what I wrote right here is the same as the number 3, so it's the same as what I have written here. The advantage, however, to writing it this way is now I have e raised up to the natural log of, I can use my second log rule on this minus sign to put this log and this log together, and I end up with x squared y squared over e cubed. I've managed to accomplish my goal of writing the exponent as a single log. Now that I have e raised up to the natural log of something, I can, informally speaking, cancel out the e in the natural log and just get x squared y squared over e cubed as my final answer. Wait, why do those cancel out? Well, two answers. The short answer is because the natural log is the log base e. So what I have written here is e raised up to the log base e of something. And this identity says when the base on the exponent, e in this case, is the same as the base on the log that is up in that exponent, again, e, whatever the argument for that log is what the entire thing is equal to. Again, informally, the b and the log base b cancel out. There's one argument for why I can change this line into this line. Here's another argument. What logs are asking you for are the exponents that you would have to raise whatever the base of that log is equal to up to make it equal to the argument right here. So what I'm doing is I'm raising this e up to some very special exponent, the exponent that I would have to raise an e up to for the e that's implied on the natural log to change it into x squared times y squared over x cubed. So if I raise e up to that magical exponent that changes the e into this stuff, well, it'll get changed into this stuff. I know that that's a hard argument to make. For most students, it's easier to just look at this and be like, yeah, the e and the natural log cancel, and this stuff is my answer now. It's no longer up in the exponent. It's worth pointing out that if this step of changing the 3 into the natural log of e cubed really bothered you, there's a way around it. Instead of using log rules, we could have used exponent rules. What I have here is e raised up to a power, and the power is something minus something. If instead of using log rules, I used exponent rules, when I have the difference of two things up in the exponent, I can rewrite that as the quotient of two different exponents, right? Remember this, it was another way to write our first exponent rule. It says that x to the a minus b is x to the a over x to the b. So therefore this is e raised up to this exponent divided by e raised up to this exponent. So I can write it as e to the natural log of x squared y squared divided by e raised up to the third power. Might be hard for you to go from here to here, but maybe it'd be easier to go from red to green. We have the same base, so all we gotta do is subtract those two exponents, e raised up to this exponent minus this exponent. The advantage to this form in red is this e and this natural log cancel each other out for the same reason this e and this natural log cancel each other out. So the numerator is just x squared y squared, and the denominator is e to the third power, the same thing that we got over here. You can see how challenging these different logs can get, especially when you put them together with different exponent rules. The good news is we now have all of the pieces that we need. This is the worst it ever gets. We have all the tools that we will need, and we're almost done with this chapter. We just have one more section where we're going to use those tools to solve equations.